So come on back to the front of the warm-up and we'll get to the stuff at the end. In a minute, I want everybody on the same page. So flip your papers back over to the front. Let's go ahead and quickly go through some of this initial stuff. So if I'm talking about the number of sides of each named polygon, we talked about all the different prefixes that tell us how many sides there are. Triangle has how many sides? Is it a polygon? A triangle? Yeah. A closed figure with sides, triangle. A four-sided polygon is called a quadrilateral. A five-sided polygon is called a pentagon. A six-sided polygon is called a hexagon. And what is a seven-sided? Okay, so whether we call it a heptagon or a septagon, this guy is going to have 7 sides. Octagon 8, nonagon 9, decagon, think of a decade, 10, dodecagon. Is he on his phone again? Last morning. Dodecagon 12, what do we call the 11? 11gon. So we need you to make sure you know those sides so you know what you're talking about. Heptagon, septagon, 7 sides. So if I were to draw a 7-sided figure, 1, 2, 3, 4, 5, 6, 7. If I were to draw a diagonal from each vertex, then I can recognize that the shape can be divided up into 1, 2, 3, 4, 5 triangles. Each triangle carries with it 180 interior angle degrees. So I know that the sum of the angles in a heptagon is going to be 5 times 180. And 5 times 180 gives me 900 degrees. If you can't remember the formula, sides minus 2 times 180 is equal to the number of interior angle degrees. Go ahead and draw yourself the simplest of shapes, a quadrilateral. Go ahead and divide it into 2 triangles, and you know this 4-sided shape, you know that has 360 degrees. So sometimes solving a simpler problem takes us back to the more complicated stuff, and then we can go ahead and derive that formula that we need to know. All right, so if I have a convex 17 agon, I have 17 minus 2 times 180. So that makes 17 minus 2 times 180 degrees. So this shape is going to have 2,700. If somebody tells me the shape is regular, what does that mean?
All the sides and angles.
So it's equilateral and equal angular. And that means that if I wanted to, I could divide this by however many sides I have to get the measure of each individual one. But I can only do that if it's regular. What's on your mind?
How would it change if it was concave 17?
So if it's a concave shape, it ends up giving us what we call a reflex angle. And this reflex angle is greater than 180 degrees. So it voids out the formula. So it doesn't allow us to use that. So anytime we're talking about using these formulas, we need to make sure that we're talking about convex, because as soon as this is concave, this reflex angle is greater than 180 degrees, and it monkeys up the formula. It's a good question. Everybody good? All right, so let's talk about 3. There are 3 steps to this problem, and I want to make sure that you can work your way through all of them. The first thing I need to do is count 2, 3, 4, 5, 6, my number of sides. Once I have 6 minus 2 times 180, and I do 4 times 180, I know I'm dealing with a total of 720 degrees that are inside of that shape. What do you think step 2 is? Why don't I call this X so we all are talking about the same thing? What do you think step 2 is? What do you think I should do next, Nick?
Add together all the other angles and subtract it from the
Yeah. So if this is my total, and I know 1, 2, 3, 4, 5 of the angles, I need to add them all together to figure out which one I'm missing. So 75 plus 130 plus 125 plus 115 plus 145. I have a total of 590 angle, or 590 degrees. So I know that 590 plus X is going to be equal to that 720. So I know that 720 minus 590 is going to be 130 degrees. Am I done yet? What comes next? What now? What do you think, Sully? What do I need to do now?
Says x and y, the angles of x and y have to equal 180. Subtract 130 from 180.
Yeah. These angles are going to be supplementary. So 180 minus that 130 is going to be y. So my measure of angle y is going to be 50 degrees. We need to make sure that we can work our way through multi-step problems and not lose track of where we are or what we're doing, or not fall short and not answer the question being asked. If they ask you for y, you first need to solve for x. Before you can solve for x, you need to know how many interior angles. So there's lots of layers in this problem. Turn to your group mates and talk about which one you think you're going to be doing on the quiz. And your mark is set, go. So I love Nora's answers. You can't make a quiz without having all the questions. So she's like, they're all going to be there. Smart person. All right, so now we have to find the number of sides of a regular polygon with an exterior angle. So there's some vocabulary words that we need to make sure we understand and how that changes our conversation. First of all, I know the polygon's regular. Second of all, I'm talking about an exterior angle. So what is the sum of all my exterior angles?
360.
So it's always going to be 360. What does this mean that it's regular?
That all the interior angles are going to be equal, which means that their exterior angles are going to be equal.
They all have the same measure, which is why I can go ahead and set up the simplest of formulas that looks like that. 360 divided by the number of sides I have means that each exterior angle is equal to 40 degrees. I continue to cheat with my proportions. Once my teacher showed me this, it made solving for my variables in the denominator ridiculously easy. So I know that n is equal to 9. So here's the deal. Let's keep ourselves straight, because this is a conversation about exterior angles in a regular polygon. Let's revisit. What if we were talking about the formula for the measure of the interior angles in a regular polygon? N minus 2 times 180 gives me my total. What if I want to find the measure of just one of them? What do I have to do to this formula if I wanted to find the measure of just one? Go ahead.
You have to divide it by the number of sides.
Perfect. So this formula is going to give me each individual angle of the interior angle of a regular polygon. This is the formula that I use for exterior. Everybody good with that? All right, so before we go on to number 5, would you right now, without peeking at anything, go ahead and list your 6 ways of proving a parallelogram, and your mark is set, go. All right, so here's my shorthand. Don't copy down my shorthand if it doesn't make sense to you. if somebody not in our class walked in, this would look like a bunch of hieroglyphics to them. None of these symbols would make sense. It's my shorthand, my quick notes to make sure I don't forget any. I know I need 2 sets of opposite parallel sides. I need 2 sets of opposite congruent sides. I need 2 sets of opposite congruent angles. I need diagonals that bisect. That's what that little X means to me. I need all my angles that are consecutive angles. I need them to be supplementary. And I need 1 set of parallel lines that's also congruent. Now that's just the order that I always do them. Like I'm that kid. You pass the quiz out, and I studied so hard, and I'm afraid it's all going to leak out of my brain. I'm going to forget it. So the top of my paper is filled with all the notes that I had to make sure that I remembered. So once I have those 6 ways down, each of them can be applied as I need them. When I look at number 5, which of my rules is going to support the math equation that I write? What do you think, God? Boy, that's my bisecting diagonals. Go ahead, Mason. Bisecting diagonals. So I know that 6x has to be equal to 72. And I know that x minus 5 has to be equal to y. Once I write my 2 equations, I step back and I look at them and I'm like, oh snap, look, this one's got 2 unknowns. There's an infinite number of x, y ordered pairs that make this true. I can't solve this. You can't solve something with 2 unknowns unless somebody gives you a little bit more information. Unless somebody walks in and goes, oh, by the way, 6 times x is equal to 72. Now that you have this second piece of information, now you can go ahead and solve for x. So when I go ahead and I solve for x, I get x has a value of 12. Once I have this value for x, I can then plug it in to here. So now I have 12 minus 5 is equal to y. Therefore, 7 is equal to y. So y has a value of 7, x has a value of 12. That's what we call solving a system of equations. When you have 2 pieces of information and 2 unknowns, you use the 2 to weave together one equation that has 1 unknown, and then you can solve that. I took my value for x and I plugged it in, and that's what allowed me to solve for y. Sound okay? All right, let's take out your homework, please. All right, so we're going to go over this super quick. But what I want you to think about as we go through is which of these questions would make good quiz questions, and I want to make sure that you understand the math behind getting that answer correct. When we're talking here, 1 through 6, about which ones are polygons, a polygon is a closed figure with sides. So 1 is no because it has curves, 3 is no because it has curves. 2, 4, 5, and 6 are yeses. Anything that dents in is concave. 2 is concave, 4 is concave, 6 is concave, 5 is convex. When we go ahead and name them, we name them by how many sides we see. Sound okay? All right, when I go to our next section, we have a heptagon or a septagon there, and however you name it has to be a ring around the rosy. So here it's already named A, B, C, D, E, F, G, so I can name it backwards, A, G, F, E, D, C, B, or I could start at a different vertex, B, C, D, E, F, G, A. So there's many different names for that polygon. As long as you've named it and ring around the rosy and included every vertex, you're fine. Nobody cares whether you go clockwise or counterclockwise. All the diagonals that have E as a vertex, anything that's a non-consecutive vertex. So E, F, and E, D are not diagonals. Just E, F, E, A, E, B, E, C. And then our non-consecutive angles are the angles that are not next to angle A. 11, 12, 13, 14, when we talk about finding the sum of the interior angles, because it's a 16 gone, 16 minus 2 times 180 is my total number of degrees. This figure to the right is a pentagon, so I know 5 minus 2 times 180 is going to give me an x value of 124. 13 and 14 are your two formulas that we talked about with interior and exterior angles of a regular polygon. Make sure you know the difference between finding an interior and an exterior. Sound okay? All right, next page. When we talk about number 1, A, B, C, and D, justifying your equation, don't give me theorem 8-3 because outside of this classroom, nobody else knows what theorem 8-3 is. So what we want you to do is go ahead and write it out. The opposite sides of a parallelogram are congruent. The opposite angles of a parallelogram are congruent. Consecutive angles are supplementary. Diagonals bisect. So we want you to be able to justify your equations that way. Are we given enough information to prove? If you have one set that's congruent or parallelogram, congruent and parallel, yes. Yes for diagonals bisecting, yes for two sets of opposite sides congruent. This one is the no. So take a look at 4 and make sure you understand that if I have these two sides parallel, nobody told me how long they are. So this side here that measures 12, what if it were over here measuring 12? Because nobody told me how long this side was. So who's to say it's not a trapezoid? That's why 4 is not enough. 5 is good because these interior or alternating interior angles are going to prove these sides are congruent and these alternating interior angles are going to prove these sides parallel, not congruent. I said congruent. I should have said parallel. When I have consecutive interior angles that are supplementary, that proves that the lines are parallel. So justifying your equation represents using one of those rationale. Just explain it to me. All right. Down bottom for each statement, determine what additional information is needed to prove. If I have AB and DC parallel, if I had those same two sides congruent, it would be a parallelogram, or the other two sides parallel. And these questions 7 and 8 are just kind of opposites of each other. For number 9, if I had DCA parallel to B or congruent to BAC, if I had these two angles that were congruent, if I knew that these two lines were parallel, then I'd be in business. These green angles give me that parallel. I would need either the angles that support AB and BC being parallel, which would be these two angles, or I would need to know that these lines are parallel. If I have one set of congruent segments of a diagonal, I would need the other diagonal bisected also. If I knew two angles, CDA and DAB, were supplementary, I would need to know the others are too. All right. So for 12, 13, 14, and 15, go ahead, check your work with mine. And in number 15, we have another example of solving a system. So notice I wrote 5x is equal to 2y plus 5. I have an x and a y. I can't solve that. I have 2x plus 2 is equal to x plus y. I have an x and a y in the equation. I can't solve that. But what I can do is combine like terms and say, hey, y is equal to x plus 2. And I can plug x plus 2 in for y. And therefore, I've given myself an entire equation that has x's in it. Once I get x has a value of 3, I can go back and solve for y. All right, in 16, 17, and 18, we asked you to use a specific method. So if I'm using just the slope formula, I'm going to find the slopes of opposite sides as if they're parallel. Therefore, ABCD is a parallelogram. This is a proof. This is a proof. Given these vertices, I can do my slope, either my calculations or put it on the coordinate plane, and then I can say that they're parallel, therefore it's a parallelogram. For number 17, just the distance formula. And again, I'm fine with you leaving your distances unsimplified, because that makes it easier for you to see that they're the same. Therefore, ABCD is a parallelogram, because I have two sets of opposite congruent sides. On the back, using one of each, I did my slope formula. And then I went ahead and plugged in the change in x and the change in y into my distance. And I proved that they have the same distance. So therefore it's a parallelogram because one side is both parallel and congruent. I liked that method the best because it was one set of calculations that felt quicker, faster, easier, shorter to me. Anybody want to argue? Did you like 17 or 16 better?
I like 16 more useful when you kind of find the slope of those pieces.
Yeah. Usually the kids are switched either between Mason's point of view. I like slope. I can do that easier. It's an easier formula, especially if you're given a graph. You can visually see it and count your rise over run. Working with just one set is an easier choice too. Just about nobody picks 17 because kids are like, if I can avoid the distance formula, I do. No big deal. I always am tickled by the fact that the same subtraction problems I do here is the values that I plug in here. The downside of that is I've screwed it up. If I mess up on my slope formula, the next thing I know, I tanked the whole problem. So we've got to be careful, make sure we don't do that. All right, so finishing this proof. I love this proof. I think it's great. It's weird that we were like given this and it doesn't start off with this given. That kind of bugs me. Maybe I'll fix that. But I've got all those angles congruent, and it took me labeling them X and Y. I started reading this, and I was a little confused at first. I'm like, wait a minute, what do they want me to do here? Okay, so X plus Y is 360 degrees. That is because the sum of the angle measures of a quadrilateral is 360 degrees. That's my justification for why that statement was allowed to be written. If I combine like terms, I get 2x plus 2y is 360, and then I factor out a 2. So that's why I wrote combining like terms and factoring. If you put simplifying or the distributive property, either one of those would be okay. What is CLT for combining like terms, and then factoring. Number 3 is the division property of equality because I've divided each side by 2. Now that I have x and y have a sum of 180 degrees, now I can go ahead and use the definition of supplementary and be like, oh look, A and B are supplementary, C and D are supplementary. Guess what? So are C and B and A and D. So then I can say all these lines are parallel because I have converse consecutive interior angles. Unit 3 is coming back and helping us out there. ABC is a parallelogram because by the definition I have two sets of parallel sides. Go ahead.
Can you go back to number 9 on the second page?
This one?
Could you also could another piece of additional information be that AB is congruent to DC? Then you have, SAS.
So I have DCA, I have these two green angles are congruent,
Mhm.
which gives me these two lines parallel, and you want them to be congruent?
If they're congruent, then you
Yeah,
have
we're good.
AC.
That works. I like it. Yeah.
So one reading about, number 9 on that page, could you also have the angle ACB equals, angle BAC?
Yeah. So these are these ones I put in yellow. If those angles are going, and that's where I start writing, or the angles. Yeah, that works. I like it. Anything else? Go ahead.
Could you re-explain number 15 on the page over?
Number
On,
5,
on the third page.
the system.
Yeah.
Sure. So when we're talking about this system here, I know that these two sides have the same length, so I set them equal to each other. I know these two sides have the same length, so I set them equal to each other. Here's a problem. This equation has an x and a y. This equation has an x and a y. So what I do here is I combine my terms. I subtract an x from each side, and I end up with x plus 2 is equal to y. Then in this equation, instead of writing y, I substitute x plus 2 in for where y was. Now what's happened is I've eliminated all my y's and I just have x's. So now I can go ahead and combine my terms and solve. Once I get my value for x, I go back and figure out what y was.
Oh, the way that I was showing you is that backwards.
Go ahead.
We just
Could
did
you
the
explain 13 on the first page?
13 on the first page.
I didn't waste time last night.
All right, so 13 on the first page says measure of each interior angle is that. How many sides does the polygon have? So I know that the number of sides divided by 2 times 180 is the total. If you tell me it's regular, then I can divide by however many sides / angles I have, and that's going to give me each individual one. So if each one is 162, I can use this to solve for my n. Now the thing is, that's a sticky thing to solve for because I've got an n in the denominator, and I've got 2 n's in the problem. So the math I need to do here is 162 times n, that's this cross multiplication here, or just multiply it side by n, is going to be equal to 180 times n minus 2. So my distributive property here and then I can combine my terms. I'm going to add 360 to each side to make it positive. And I'm going to subtract 162n from each side. What does that give me? 18? 18 n's?
Yeah.
So then when I divide by 18, that's how I end up with n is equal to 20. Somebody in the other class, instead, listen to how slick this is. Oh, do you know what they did?
Yeah.
Go ahead.
They got the exterior angle from that, and then they divided 360.
Then they use this formula.
Yep.
So if this formula is too intimidating for you, go ahead and find the supplement to this, and then divide 360, or 360 divided by n is going to be equal to its supplement. So that's kind of a slick way if you want to use exterior angle. Are we good? Yeah? Okay. So after the quiz, I want you to pick up a sheet of shapes, and you can see that this one has this squiggly line around it. That's because when you cut the shapes up, I don't want you to go super tight on how you cut them, because we're going to be making conversations about and doing congruent marks and whatnot, and it's easier if we do that when the sides have some edge around them. Plus, it's a lot faster to cut them out if you don't have to be precise. Does that make sense? So you're going to cut all the shapes out, and you're going to start on this side of the worksheet. You're going to take your quadrilaterals, you're gonna sort them into groups that belong together, you're gonna write the pieces for each group and then your justification for that group. Like I put these together because. And then you're gonna mix them all up and you're gonna find another way to sort them and then you're gonna mix them all up and find another way to sort them. So, for example, if I was to sort this class, maybe I wanna sort it into the kids that are in a performing art. Are you in band, chorus, and orchestra? Are you in sports? Are you, you know what I mean? So maybe whatever classifications, okay? Maybe we'll talk about the kids that live in walking distance or the kids that ride a bus to school. Or so there's a bunch of different sorts that we can do. So I want you to come up with 3 different ways to sort and classify the quadrilaterals. Does that make sense? Okay. Awesome.